We didn't show you this T-tape, but like all the T-tapes we've done, they're all pretty basic. Before putting the T-tape on, we showed you sanding this, what we'll call the aileron shear web, to match. The skins are just about 5/16 of an inch thick in this area, so you have to position the lower skin, which I just happen to have right here. And you'll notice I have this taped here. Well, I had it taped fully when I T-taped it, all the way from the center line of the tube out to well beyond the influence of this tape. Got it fitted first, after we've already been through the fitting of the upper skin. Trim this down, drop this in until it was just below and tangent to this surface right here, which means you want to iteratively fit this and the trailing edge of the bottom skin at the same time, lest you over trim this skin. The fit between here and here, very, very, very important. So you put down the tape from this position right here down its entire length, just behind the leading edge. You do 2 plies of bid for a width of 2 inches. You can see right here. And while it's wet, you brush on resin onto the bottom of the shear web, pack on the dry micro, and squish, which means you have to have positioned this previously and made it certain that it fits just the way you want it. And then if you have to, super glue pieces of tongue depressor, wood, whatever, on the bottom to hold it precisely where it is. Let it cure, pop it free, trim it down, sand the back side of the bottom, put in your flocks in the corner, and then 1 ply of bid on the back side. After having done that, allow the cure, trim, and then we're going to make up. You don't have template for this, but you have stock for it as your rib. Notice the flock's corner right here. I'm leaving the foam in along that edge, and I'm only filling the outboard edge, which is the surface that touches the outboard skin along this edge here. I have a piece of 032 aluminum stuck between the two, loosely. Now I'm going to position them here and glue them on with flocks. I'm going to do the same thing with the inboard end, and that rib looks like so. There's your flocks corner right along here. Trimmed out for a torque tube. So we're going to bond it in place. And we'll probably fill this up with flocks, brush-in resin. Very, very, very carefully brush-in resin, only where the flocks is going to make contact. Stick it in place. Now we may not succeed at this, but it's our intent, is to stick it in place and then apply a blob of 5-minute and 5-minute right where the tube is here, but the 5-minute cure, and then remove the entire thing, and then put the 2 middle ribs in, and you take this distance, which is 71.5 inches, divide by 3 for 3 spaces. It's not divided by 4 because it's 4 ribs. It's divided by 3, which gives you around 23.5 inches or so. And then you fit a rib here, which runs about that length. This rib is only seeing compression, so it's bonded in very, very lightly with 5-minute epoxy and micro. We'll do that a little later in the show here. So we're going to accomplish all these feats, and then we'll be back with you. Hello, we're back. Sorry for jumping around on things here, but I know we've got things curing on the other side. We thought we'd do something here that's a little more on the mundane side, but necessary. So you have a block of foam. You want that block of foam just a little longer than this. And we're going to put it on here and, pardon me, but we're going to smack it. Pretty good fit. We've got about a quarter inch or so in that corner. So I'm not going to carve beyond this yet. I've already sanded the interior, Mr. And I haven't hit the bulkhead yet, but not important. So I'm going to mix up my 5-minute and goop it in here really good. And Then I'm going to take some of that, I'm going to smear it on the inside and then squish. The amount of foam that I have lapping onto the inside of this is of no concern. We're not going to fill up this area from the backside with foam. Nor are we going to glass the inside of the rib. No concern. It's just an aerodynamic fairing at the tip. So there we are with our fit. We have enough material in the front, enough in the rear. We're going to go right to 0 here when we do our carving. Next, 5 minutes. We're back in a second as we're squishing it in plate. I'm on. Okay, as you can see, I'm just smearing this stuff here. Doesn't require a full bond. It's just the surfaces upon which the glass will go later. The glass is doing all the work. Let's get a little bit right there on top of that. Right in there. And, as they say in my country, okay. Now we did something before I put this on. I looked inside, made certain that that rib was drilled. Make sure it can breathe later. And look here, we'll be back with you in a moment. We're firm. Now what we're going to do is we're going to saw off the flashing with a bent saw blade, riding on the surface. So as to make certain I do not remove excessive material. See how I'm bending the blade? I'll do that on both sides. Then I'll take a sanding bar with duct tape on this portion of the sanding bar. So I'm not sanding my surface, sandpaper riding here. It will leave me this depression here too high. I'll be flush with the outside. I don't want to be flush with the outside, but I get close first. Then I work it on, once I get the sides parallel with the projected surfaces, then I'm going to cut my plan form from the side. We'll do that in the next step. Okay, we've carved it down, removed the excess 5-minute epoxy that was here, but it's angled up towards me so that I've developed, I haven't done the other side yet, but I will eventually here. I'm going to develop a block form of this tip. And after I've done the block forming, then I'm going to leave a little bit on the edge here. It's going to go to nothing eventually, but leave something behind. And cut off the tip. I suspect that this will end up a little flatter here, that you want the leading edge tangential to the tip. Now I'll get the other side parallel to this, then we'll start rounding it out. Okay, we have squared it up. I think riding on this flat here, which I should have sanded this earlier before I started shaping my foam. Get this thing completely sanded because you'll do more damage to your foam in preparation for your final glassing than you will from any other portion of your shaping. Get that done first. Okay, now we've got it square formed. And I think that we can bring it down here a little bit more. And try and look at this tip as though it were part of the whole, not as though it were something sitting on top of a diagonal line. It will make it an awful lot easier for you to get an entire perspective. This width and this height should be about the same. And presently we are a lot higher here than we are wide, about 1 1/4 times. So it would be wise for us to bring this down. This will look like an airfoil, relatively flat at the back. But its thickest section should be about here, where it is thickest. What makes this doubly difficult is that I am more concerned with how you see me doing this than I am at the actual process, making it difficult to shape. Such is my lot. The precise shape of the tip is unknown. What should the shape be? How best to shape it to decrease potential drag? We also have to deal with the aesthetic. But I would stay away from shark fins. Don't do anything to increase the wetted area. Make the shape smooth and pleasing. Now we start with taking off corners. Height and width. Okay, I'm still too high here. I don't want to increase my span any more than I absolutely have to. Okay. My width is still okay. Before you start your carving of the corners, you should make certain too that this plane is average to both surfaces, not favoring one or the other. How about looking, Burt, from your POV?
Good. If you don't move around too much, then it stays blue.
Stays blue? Okay.
Now it's white. Those are very good.
Okay, here we go. Now, I don't necessarily have to have a block.
Stay there.
Sorry about the muting. I can place a line down the approximate center. Hey, Frederick. And that'll help me see my average center of radius. What you're really doing here is you're trying to work half circles. You have a width here of 1 inch, and what you want is this radius to come around the surface as a half round. That is essentially the process. Get rid of the little facets. There should be a cone from the small radius to an increasing radius all the way to the thickest portion. Take your time, and we're getting very close to putting on 2-ply bit. Last time we were on, yes, bingo, it's recording. It turned itself off, Misha. Okay, we're back. Hello. Okay, Misha, you still got me?
Yes.
All right, we're having trouble with our microphone, so I apologize. Okay, so we've done that to both ends. Cleaned it up, trimmed it up. You can see some of the old 5-minute. Follow me on that. You can see the old 5-minute that's in there.
Yes. Yeah.
You held it?
Yeah.
We're not going to tape it. It's rock solid on the ends. Now the next thing we're going to do is put bulkheads on the inside, and they're only going to be 5-minute epoxied in place. You measure the third, I talked to you about that before. You fit them. We're going to mix 5-minute epoxy and bond them on edge. They're going to go in like so, and then wipe in, bond in place. Can you see that easily, Mishka?
Yes, sir. Full.
And the next one, same way. You notice I've got a lot of extra material hanging out here. We let them cure. Then we cut them off. We trim until they fit precisely. Once that's done, we sand the trailing edge about a 1/2 inch wide. We do a flox corner here again. And remember, a flox corner, we don't do anything to the inside skin. We remove foam diagonally at 45 degrees to the interior surface of the exterior skin at a 45 degree. We sand that glass, we put the flox in, we leave it a little high, and then we pot the top on in place. We sand this surface its entire length. I've drilled through the skin into this T-tape corner where the micro is, where the glass goes into the rib. I'm going to use drywall screws to squeeze it there. So in effect, what I'm going to do is brush this with resin, flox, brush this with resin. Same thing here. Then I'm going to put a thin bead of flox down this leading edge, or in the case of the wing, the green stuff that I've used in the past down here. And then a thin bead of micro on top of the rib, and a thin bead of flox or green stuff down the trailing edge. Then I'm going to assemble it on the wing. Cleco's in place, the trailing edge being squeezed by a straight edge on both sides, making certain that it stays straight and aligned with the leading edge, while this leading edge of the lower skin is perfectly in line with the underside of the wing. And we'll step through that process when we get to it next. We have performed the dirty deed. And you notice the 5-minute epoxy is not showing. It's because just as it sets, I cut it off and remove it. I got a little sticking out here. Pretty good bond. You know, I could hurt myself trying to take these things off of here. And they're only in compression, so keep it light. Don't overbuild it. Now we're going to fit the skin to it and see how it fits. Oh. Okay, so I'm going to take a straight edge, cut that off, and be back with you in a moment. Since the last videotape was done, long enough ago, 2 or 3 months, that there have been some changes made to manufacturing. One of them you can see clearly here. Misha will show this. Michael Schuete's ailerons were the ones that you saw, center on this, Misha, were the ones you saw me assembling. And the tube was bagged in place. It was hard for me to control the placement and the consistency of the tube's relationship to the shear web. So I decided to mold a 3-ply layup that I had my guys bag in place, and it keys into the corner, resulting in a depression that is always precisely in the same place. So consequently, those of you who have ailerons that don't have the torque tubes, it's real obvious where they go. You'll find a depression and a 10-inch tube. You'll place the tube in the depression and Cleco and pop rivet into place as you do your assembly. You remember when we Clecoed, or we pop riveted your hinges in place on the exterior, you made certain to drill through the hinge through a layer of aluminum that's buried inside of your aileron, and resultantly ending up in the center line of your tube. Well, you'll have to control that a little more on this one, but the results will be the same. You'll clean up the tube first, bond it in place, pop rivet it, a small amount of flox in each corner, 1-ply glass over the tube, and then finish up with all your pop rivets. The T-taping here, when we did this T-tape, we filled between the tube and the T-tape with micro. The glass over the surfaces and the micro makes this particular load transition point bulletproof. We also T-taped previously and then put in the ribs. Well, Misha did it a little differently, and I approve of the method. He installed his ribs first, trimmed them down to match, and then his T-tape picked up a portion of the rib on this side. Now, they are only microed in. In the previous bit of tape, they were 5-minute epoxied in place, which is still approved. But you can either micro them in or T-tape them. You can see that this has also been filled with micro, and then it was closed as though it were a T-tape operation but without the glass, giving you a nice surface to bond to. Now from there, we're going to go into bonding. And the last step is just bonding this skin to this surface. Sanding, 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 sanding this surface on the interior end, sanding all the interface surfaces on the aileron, lower skin. You notice that we've sanded here. He hasn't sanded here. We will sand this as well. We'll sand everything in preparation for bonding before we do so. This will be sanded as well. When next we return, we will have brushed on resin and gotten out our bonding materials. We're going to use flux in this application, although if I had some at the moment, I would prefer to use the green stuffs because it is a lighter material. Back with you soon. Okay, sorry about that. We did the operator. We have an extrusion that's clamped on, flush with the back end, and it's a straight extrusion. And it just flaps up against the surface. I can open this up. I can apply my material. I'll probably apply it without this in the way, but you can see it's not difficult to hold it in place. One little C-clamp here on the end. This clamp on the inboard end. It's solidly attached. You might want to cover it with a release film of some sort because the squeeze out is going to end up on the surfaces. We'll apply our resins and we'll be back with you in a moment. We're just going to apply a few little droplets here and there and then smear them to a thin coat to make certain we have bondage. And a small amount to the trailing edge here. So we're going to squeegee out and we'll smear this stuff. You've seen this before. We'll be back with you in a few moments.
Ready.
Ready, shoot.
Ready.
All right, you're shooting?
Yes, sir.
Okay. We're back. And you notice the Gouchon Brothers green stuff? Well, we ran out. We're using a clear product that you can't see from the backside. And it's smeared on the side, but this material is manufactured by Pettit. It's a little thicker. It's a very strong material. So it's been tested. We've tested it. But we'll stick with the 277, 175 product to recommend here. All right. This surface has been smeared, wetted with a very small amount of the same material. Squeezed around. Let's make certain that we have no problems with adhesion. Now we roll it over. I change gloves. And Mr. Ken Palmer, Berkut builder extraordinaire, is going to keep it up off the grab a hold anywhere you want. And you're going to keep it up off the surfaces while we slide it down here. Bring it down into your just above the trailing edge with your forefinger here. And let it rest on the trailing edge. Okay, close the trailing edge, just let the front end lay down. Okay, now we rotate. And we have this just at the height of the trailing edge. And I want my aileron skin to be at the same height. Now I'm going to clamp across here. I'm also going to run some tape so it can't slip or slide. But while I'm preparing to do that, I'm going to go get these clamps. I should have them right here in my hot little hands, but I don't. So we're going to stop the tape here. I'll be back with you in a moment. The old expression is there are many ways to skin a cat. Well, depending on what your extrusion shape is like, depending on what kind of clamps you have, I could have run an extrusion across here and had deep clamps and squeezing on it, but what I've done here is I took tongue depressors, put them into the grooves, and you can see there's quite a bit of spring pressure pushing on the aileron. So I pushed the tongue depressor over and super glued it against the bottom of the skin. That will certainly serve well to make certain that this is up against its shear web. Okay, sorry for that stoppage. Here's how I'm going to actually do it. We're going to put this inside. You can actually see it pressing. So I put a drop of super glue here, if it'll cooperate. Super glue. Okay. Zip. A splash of zip kicker. We put it in place. We lever it. We hold it. And now the ribs that were in there before, we make certain that they were all drilled so they could breathe. We'll have to talk a little later about letting the aileron breathe to the outside atmosphere. I haven't exactly decided where I'm going to have the aileron breathe to, because I don't want it collecting water. That could be rather bad for balance if that water happens to be in there and then freezes in position at altitude. Essentially, this is how we're going to let it bond. The next step will be, after it cures, we'll take it off and we'll run 2 plies of bid from this depression around the leading edge and just underneath the hinges. Be back then. Okay, the aforementioned holes that I was referring to, we're showing you the other aileron. You can see right here in the corner, they're 3/16 inch to 1/4 of an inch on the upper surface. There should be holes drilled at the bottom as well, bottom low. He's got them drilled a little high here. And they should be drilled as low as they can so water can transfer back and forth if it should collect. The decision as to where we're going to put in the holes, we may end up with one at the trailing edge, bottom and inboard. My concern is that the holes that we put in are also the holes that can provide access for water to enter. We want the aileron to breathe, but we don't want it to collect water. The definitive on that a little later. Good. Good morning. When last we spoke, we were putting together the aileron, bonded it together. Now we're going to show you the elements of assembling the torque tubes, push rods, and belt cranks that operate that aileron. First of all, we'll cover the uniball receptacle, self-aligning bearing, NMB. I forgot the part number, my apologies, but it's listed in your manifest. The receptacles are machined to a closed fit, and there's a circlip groove, right here, and you need circlip pliers, the bearing, the receptacle, and circlip. Now, Chris, if you'd follow me, please, down to the table here. I want to show you the appropriate way to grab a hold of a circlip for this application. Take your circlip pliers, making certain that the ends of the pins are nice and square and sharp. Push them down to the surface and squeeze. The circlip bearing, move a little more quickly, right to the subject. Drop into the circlip groove and release. That's what it's going to look like. Now we have a small problem in that the area under the clip, can you clearly see that? Focus up to it. This area right underneath hits the ball. I'm going to show you what that looks like. Now, for removal, I don't have to worry about what I just showed you. But we'll drop the unit bearing in place. It's a very close fit. Oops. Next. Okay, now we have the circlip. And we release it. Now what's happening is that this portion of the clip right here is hitting the ball. So I have to take it to the grinder and I have to grind away underneath the clip so it just clears the ball. The ball does not rotate during normal use. All it does is self-align. That's what it's supposed to do. The tube itself rotates inside the bearing, not the bearing rotating inside of its cavity. The bearing is supposed to be inherently stiff. And I'll grind these circlips and I'll show you the results in a moment. All right. Chris, can you see that in the video? Mm-hmm. See this corner right here and right there has been relieved. The bearings clip in, and then make certain that the ball moves the way it's supposed to. This one's a little loose. This one's been floating around here for ages and been beaten up and banged around, so it's not as tight as it usually is. But because of that, I can tell it's not rubbing on the ball, on the clip is on the bearing. Now the next element of this operation is a 3-inch by 3-inch, 1/8 inch thick phenolic plate. Now you notice I've back set it about 5/16 of an inch. I'm going to bevel that to nothing on 3 faces. This corner, this corner, this corner. This will be the surface that rides along the upper edge of the inboard end of the wing. And the unit ball will ride right here. This will be grit blasted. This will be sanded on the back side. Of course the bearing won't be in there, and I'll have protected the inside surfaces, the surfaces that I don't want to grit blast. And then I'll drop them in place, and before they're fully through, I'll put flocks around them and then squish it in place. And then where these grooves are, I'll put flocks around the part, and then 2 plies of glass on the backside lapping onto the sanded areas and allow to cure. Then we'll install that as a unit into the inboard end of the wing, which, if you recall, received an extra ply of glass after it was bonded in place, so that the effective exterior is at least 2 ply, and there's a ply of tape around the upper end as well, where the T-tapes are. I'll be back in a moment as I progress with these processes. We're back. There's the phenolic, the before, and the after. You notice I've sanded the back. I sharpened the edges after I drilled the hole. So drill the hole, sharpen the edges, and then grind the hole. Well, probably drill the hole, grind the hole to the fit so it drops in, and then sharpen the edges. You'll find that holding on to the sharp phenolic while you're grinding is not much fun. So no sanding on the front face is necessary. This is your finished part on this side. We can cleco it into place before bonding it. We can cleco fit it in at any time prior to bonding. But I think that what I'm going to do next is I'm going to grit blast the perimeter, insert bonding with West flocks on the outside, a nice tight radius here around the perimeter, and 2 plies of bid, allow to cure. We'll be back to you at that stage. Hello, here we are. Okay, some of you like more information than less. Just Chris, follow me. Yeah. All right, here we go. I've mixed up 1 shot of resin. To it, I've added, I have a second cup of dry flocks, mixed flocks. They're all done with 1 shot of resin. Now I brush the resin onto the receptacle. Now I just grit blasted this moments ago. Now most of you don't have a grit blaster, I understand. Plans have described what you would do with that. Just wet sand it with resin with 150 grit. Now I'm going to set this down. I'm going to brush a little resin on the inside and on the back. And the ring. Okay. From the front face. No, wrong one. You drop it through. Before I pull it all the way through, I'm going to put a little bit of flocks on the sealant, the depressions. And I'm going to sort of twist it as I push it through. None of the flocks here on the outside is doing anything except making a bit of an ugly mess. Now, holding it in place, I would probably do this against the surface. So let's move down to pointing at the table here. My flocks are a little bit dry, so I've just added some resin to it to make it move a little easier. Oops.
There we go.
Got it back? Do this all the way around. Sorry about the mute. And then I'm going to put one ply bit on it. We'll be back in a moment. Got me? Hello, hello. Yeah, we're starting from the scrap bin here. I'm going to cut a square cloth. I'm going to cut it oversized. Now, pan quick. You can see it covers the part well. And I should be able to, if I fold in the center, I look at the size of this part and I figure, all right, I want to cut away. Let's see if I've got it. Huh. All right, Joe, he gets lucky. Now, if the flocks was big enough, then I'll be able to take the cloth all the way up the wall. And when I say big enough, I mean a large enough radius. Then the cloth won't care if it's got a 45-degree orientation to an edge or a 90-degree orientation, because obviously I'm going to have 45s in some places and 90s in others. And we want the cloth to come up the walls all the way around. So I wet that. And I'll do that a second ply here. Be back with you in a moment. Okay, the second ply I'm going to do as a tape. I don't have to go all the way around because what's happening in the front and the top here is rather superfluous. It's okay to leave it sticking up above the surface. All done with a single shot of resin. Now this, I'm using 205 because I want to push this cure cycle so that 45 minutes from now, half an hour from now, I can show you more of the same process. I'm going to toss this in my oven. If you have an oven at home, you can stick it in a 120-degree oven and push it rather quickly. No bubbles. Allow to cure, trim, which is how you'll see this part when I next return for our next section. Okay, we're back. Notice it's all been trimmed out, cleaned up. Now we're going to sand all of the gloss off the back side here. All of this. All the way around. This has been trimmed
I put it on the 3M wheel, took the epoxy off the surface. Same thing on this side, 3M to clean it up. Took all the goo off of here. So take the gloss off the back side. Make certain that there is no epoxy left. Oops, wrong side. I'm watching the video monitor, and make sure it drops in. Click, nice fit. And now we're going to go show you the positioning of this on the inboard end of your wing, and this will be the left wing. Before you have the inboard end of the left wing. The brackets are of Misha Kasyan's airplane, and the positions of these are called out on your drawings. The inboard end of the bracket is 1 inch in from the end of the wing. Now, if you've misplaced this bulkhead and it bumps the end of your bearing, then of course you need to move it inboard. It's not ultra critical here, because you're going to do several things here that aren't necessarily affected by the exact position of this bracket. What I do is I place this portion of the lower bracket 1 3/8 inches, you can't read it, but it's 1 3/8 inches to 1.5 inches above this surface, and this parallels the spar. This gives the inclination of this bracket slightly high here and slightly low here in relationship to the absolute horizontal. But it points this end of the belt crank right at the actuating torque tube and control horn at the firewall. Now, Chris, if you move up to this point, this dimension is also given to you in the drawings. It can float as well, as long as the position you choose, you see these 2 holes here, represents the bulkhead that isolates this aft bay from weather. This aft bay is likely to get water in it because its outboard end is open to the weather at the aileron torque tube. Any water that enters that bay drains at this point after the bulkhead. So anything after this bulkhead that clears the torque tube is okay. Misha's torque tubes are already set to length from his previous foam wing, so I'm not going to change them. I could move them. You notice this condition here. I don't know if you can see it, but I have a line drawn there. What I want, when this is in position, is I want a 90 degrees from the center line of this tube to the center line of this belt crank to where my torque tube is going to be. Now, I could lengthen these, but there's no reason to do so since my 90-degree position results in a position well aft of this bulkhead. So I'm going to choose that point, move my bearing all the way up. And notice I'm upside down, of course, but it will be drilled in that position, approximately there. I'll cut that with a hole saw. I'll radius it to match these curves here so it goes up against the surface flat. I'll sand the area. I'll bond in place with flocks. I'll drill 2 holes before I start and hold it in place with either number 40 or number 30 Clecos. Remember the criticals here are the 90 degrees between the 2, which can be established by push rod length. The height of this bracket between 1.5 inches and 1 3/8 inches, 1 inch inboard. Now you also notice that I have a bolt going through this belt crank. This keeps this belt crank in the neutral position. I've drilled a hole by placing the CS127S's together, drilled a common hole, and then made certain that this belt crank was in common plane with that hole, allowing me to pin it in the neutral position, which makes the setup of this whole geometry very, very simple. So the next thing I'll do is I'll drill this hole and open it to match the curves and Cleco it in place. Okay, we're back. What we're going to show you here is that we've taken a drill bit that is approximately the diameter of the back side. Let's see if I can get this viewed here. This diameter here is the diameter of the base of this, where the bottom of the bevel is, the corner. And the hole I've drilled now for this diameter in the center is I'm drilling next. So we'll do that for you here real quick. And I'll go right on through. Now, having removed the exterior skin first and then the back skin, I've established my bevel. Trying to make this as easy as we can. In a moment I'll remove this ring and we'll do the inside. I can clearly see that the bulkhead in the back side of the outboard member is well away from this area, giving me plenty of room for my torque tube. Okay, what we've got going here, you're looking at, is the slotted opening at the inboard end. You can see my finger through here where the control horn travels. There'll be a universal joint attached to the end of the aileron at this end. The torque tube and exiting here. Now you'll notice our fit here drops right in, flush. And there's sandwich around the backside. I'm going to drill it for 2 clicos, about mid-span here. 30s, 20s, 40s or 30s will do. I'll brush resin on the surfaces, loose flocks, and clico. Allow to cure. We're back. There's the 2 clicos, fits flush. I'm going to mix up some West resins. 105, 205 will be sufficient for this. And back to you in a moment. We interrupt this portion of the program to give you a special bulletin. We've been on push rods, obviously, but what we're going to do is show you, since we want to get this thing bonded together tonight, if we bond it all down, you won't get to see the process. And it hasn't been shown in any of the previous videos. You'll need a counter bore, 3 flute, number 10 pilot, standard 100, I've forgotten the taper. Basically the taper of the AN509 screw. You're going to use these 2 devices. Here, the counter bore is flat on the end with a 3/16 inch pilot, number 10 pilot. The counter bore is the diameter of a Timmerman washer. Misha, why don't you cut the tape there, and we'll tell them what that diameter is. You notice the diameter of the cutter is 751, 752, in that range. And the diameter of the Timmermans are also 750. If you have a problem with sizing, you stack a bunch of them together, you put a bolt through them, stick them in a lathe, and file them down to size. So you can file them down 10 or 15 thousandths without a problem. But they should key into the depression. You'll notice if I put it here inverted, it keys right into the depression that's been made for it. Now, counter boring has already been done, but essentially you have to move through it iteratively, pushing and staying flat against the surface and make the cuts. Checking to make certain that you have resultantly gone the thickness of the material. Now, if you intend to put a Timmerman in here, I also suggest that you add a few extra plies of material here over the ones that I have suggested in the plans. Now, the second step, after doing that, is to set your microstop to the appropriate depth. And pick a microstop that has a 3/4 inch diameter on the end. If you don't have one, machine it to 3/4 of an inch so that it will key in. The amount of material that you will remove from here will be substantial enough that you might lose the pilot. And if you do, you will lose your reference. That's why it's so important that when you're done, you counterbore at the right depth and you countersink at the right depth. Now we'll grit blast these, and this is paramount. You have to grit blast them and bond them in place with at least West 105-205 or 105-206 or Hysol or JD Weld. But the grit blasting is imperative, and that it's imperative that they be clean and absolutely free of any kind of dirt, because this will do the job of load distribution and bonding to the surfaces, which will greatly strengthen the area. That will generally cover this entire issue.